Long dismissed for centuries as food for the poor, cassava has not only quietly saved millions from famine, but has also emerged as a cornerstone of the global food industry, now worth over $10 billion. But have you ever wondered how over 300 million tons of cassava are grown, harvested, and processed every year? The journey of this humble crop begins in vast cassava fields, where farmers and machines work in harmony to unearth each root from the rich red basalt soil. From there, the cassava is transported to modern processing plants, where advanced technology and human craftsmanship work together to transform the rough roots not only into versatile, pure white starch, but also into a key raw material for animal feed, pharmaceuticals, and biofuels, such as bioethanol and biogas. Today, join Agriculture Insight as we journey through vast cassava fields and uncover the starch production process inside factories equipped with the most modern, sustainable, and environmentally friendly technologies. Everything will be revealed in this video. Just one cassava root can take a life, if not properly processed. It may sound exaggerated, but the truth is that cassava contains cyanogenic glycosides, which when broken down release hydrogen cyanide, HCN, a deadly toxin that can cause death in just a matter of minutes. Despite its inherent risks, cassava is a paradoxical crop that humans have domesticated and spread across the globe since the 16th century, primarily through colonial empires, where it quickly became a staple crop and laid the foundation for a multi-billion-dollar starch industry. And from there, throughout history, cassava has time and again played the role of a silent hero, saving millions from famine across Africa, China, India, and even during the Vietnam War. That's why, in Africa, cassava is seen as a symbol of life and the unyielding will to overcome hardship. Compared to potato and sweet potato starch, cassava starch contains a higher starch content of up to 80 to 85% and stands out for its strong thickening power, high clarity, neutral taste, and low cost, making it ideal for both the food and industrial sectors. Like every legend, the journey of cassava begins with Mother Earth, where humble cuttings grow through sun, wind, and time, beginning a new life cycle for a crop that nourishes millions. In early spring, as the land welcomes its first rains after the dry season, weather conditions become ideal to begin a new cassava growing cycle. Unlike many staple crops that are grown from seeds or seedlings, cassava has a unique trait. It is propagated using stem cuttings from the previous harvest. Healthy cassava plants are carefully selected after harvest to serve as mother plants, a crucial step as the quality of the stem cuttings directly affects the sprouting rate, growth performance, and yield of the next generation. The selected stems are then trimmed into cuttings measuring 20 to 25 centimeters, each with 5 to 7 healthy buds to maximize sprouting potential. Before planting, these cuttings are often treated with antifungal solutions to prevent root rot and pest damage. Another important factor is soil preparation. The land is deeply tilled to a depth of 30 to 40 centimeters using mechanized plows, creating optimal conditions for root development and making future harvesting easier. A common planting distance of 80 by 100 centimeters provides enough underground space for tuber clusters to grow, while also ensuring compatibility with modern harvesting machinery. Today, in many specialized farming regions, cassava planting has been mechanized. Farmers use specialized cassava planters that can simultaneously create furrows, place cuttings, cover them with soil, and press the ridges, all in a single pass. Such machines can plant 1 to 2 hectares per day, significantly reducing labor and saving time. After planting, a light watering may be needed if the soil is dry. Within 7 to 10 days, the cuttings will take root and sprout, beginning their gradual transformation into full-grown plants. An interesting fact is that the long, pointed lobes of cassava leaves are sometimes mistaken for cannabis, a surprisingly common misconception in both rural and urban areas. With proper cultivation techniques, cassava plants can reach a height of 1.5 to 3 meters, with vigorous root development that leads to high yields at the end of the 8 to 10-month growing cycle. This marks the foundation for a bountiful harvest, completing a journey that began with humble stem cuttings. At large-scale cassava farms, modern machinery is brought in to streamline operations. On wide, flat fields lined with neatly arranged rows of cassava, specialized harvesters move steadily along the beds. At the front, rotating blades swiftly clear the mature stalks. Immediately behind, a set of digging blades sinks into the soil, gently lifting the entire root system and pulling out clusters of cassava tubers. As the machine completes a row, the cassava plants vanish, leaving behind loosened soil and exposed roots near the surface. Workers then step in to collect any remaining tubers by hand and place them into large baskets or sacks positioned along the rows. Once full, the sacks are hoisted onto waiting trucks at the edge of the field. The entire process is smooth and efficient. Each pass of the harvester can save hours of manual labor, dramatically increasing harvesting productivity, especially during peak seasons. In smaller farms or areas with sloped terrain, hard soil, or irregular planting patterns, cassava is still harvested by hand. Though more labor-intensive, this traditional method can still be highly effective when done correctly. In loose, well-aerated soil, farmers can uproot entire cassava plants by hand without the need for hoes or crowbars. They then use specialized knives to separate the root clusters from the stems and gather them into baskets or sacks. It's a physically demanding task that requires strength, patience, and technique, especially under scorching sun or in hardened soil. In some regions, farmers first cut the stalks, then use a digging tool to lever the root base out of the ground. Once lifted, the roots are shaken clean, separated from the cluster, and placed into containers for transport. And when the trucks are finally filled to the brim, they roll away from the fields, marking the end of a fruitful harvest season and the beginning of a new journey, as these soil-covered cassava roots are transformed into pure white starch, ready to serve the food and industrial sectors. As soon as the trucks arrive at the factory, the cassava roots are unloaded at the receiving area and temporarily stored in a holding yard. Depending on the scale and capacity of the facility, the plant can handle up to several thousand tons of fresh cassava per day. At this stage, a preliminary inspection is carried out to remove damaged, rotten, or heavily contaminated roots before entering the processing line. At this stage, the raw cassava roots are divided into two main processing streams, depending on their intended end use. One portion goes through the dry processing route, where the cassava is thinly sliced, typically to a thickness of 3 to 5 millimeters, to facilitate faster and more uniform drying. It is widely used in the animal feed industry due to its high energy value and also serves as a key input for fermentation-based industries, such as the production of bioethanol, vinegar, organic acids, and various other bio-based products. The other portion is directed toward further processing into refined cassava starch. From the storage yard, an automated conveyor system continuously feeds the selected roots into the cleaning section, marking the beginning of a fully enclosed and high-capacity processing line. From the receiving conveyor, the cassava is transferred into a continuous washing system, typically a horizontal drum washer. This machine operates by rotating while internal spiral paddles and high-pressure water jets work together to remove all soil, sand, mud, and the thin outer skin from the surface of the roots. As the drum spins, the cassava roots tumble against the rough inner surface and against each other, causing dirt and skin to peel off naturally without the use of chemicals. In industrial processing, cassava roots are not completely peeled as they are in traditional methods. Instead, they are thoroughly washed and mechanically cleaned to remove dirt and the outer skin, allowing for maximum starch retention. As a result, a certain amount of cyanogenic compounds, primarily linamarin, may still remain in the roots, especially in bitter cassava varieties. And to eliminate this natural toxin, we must now take a closer look at the critical processing steps that follow. After washing, the cassava is passed through a manual inspection stage. Here, workers remove any damaged, bruised, or diseased roots that machinery might not detect accurately. The selected cassava is then either cut into smaller pieces or left whole, depending on the requirements of the next step, grinding. At this stage, the cassava is fed into either a roller crusher or a high-speed blade grinder, where it is crushed into a pulp. This mixture consists of starch dissolved in liquid and fiber that has not yet been separated. This is a crucial step that breaks down the cellular structure of the roots, allowing for the maximum release of starch from the raw material. The pulp mixture after grinding, consisting of starch dissolved in water and undetached cassava fiber, is transferred to a centrifugal or vibrating screening system, depending on the technology used by the factory. In a centrifugal sieve, the mixture is pumped into a high-speed rotating drum covered with a fine mesh screen. The centrifugal force pushes the mixture outward toward the screen, allowing the fine starch and liquid to pass through the mesh, while cassava fibers and larger impurities are retained and discharged separately. The separated fiber doesn't go to waste. It's collected and used as rough animal feed, as it still contains a small amount of starch and beneficial fiber, making it a nutritious meal for our cows. Do you agree with these, Moo? The next step is dewatering. Various methods are used depending on the scale and level of automation of the factory. At medium and small scale facilities, a filter press is commonly used. In this system, starch slurry is compressed under high pressure between thick filter plates, effectively removing most of the water from the mixture. The result is a semi-dry starch cake with a moisture content of around 40 to 45%, which is soft, white, and moldable. This semi-finished material is essential for the subsequent drying process. Although the filter press operates in cycles, it is easy to maintain, simple to operate, and well-suited for medium-capacity production lines. In large-scale industrial factories, where high output, continuous operation, and full automation are required, the dewatering process is typically upgraded to a rotary vacuum filter. This equipment uses a rotating drum combined with vacuum suction to continuously extract water from the starch slurry. As the drum rotates through the starch tank, a thin layer of starch adheres to its surface and is gradually dried by suction through a filter cloth. This is also a critical stage for removing most of the natural toxins found in cassava roots. After grinding, cyanogenic compounds are released and dissolve into the water. Through continuous steps of fiber separation, filtration, and dewatering, the majority of hydrogen cyanide is carried away with the liquid waste, significantly reducing the toxin content before the drying phase begins. During the dewatering process, a large volume of wastewater is generated from stages such as root washing, grinding, sedimentation, and filtration. This wastewater contains residual starch, organic matter, and suspended solids, which, if not properly treated, can cause serious pollution to surrounding water sources. To manage this, factories typically implement multi-stage wastewater treatment systems, including primary sedimentation, flow equalization, biological treatment, and final disinfection. Some modern facilities also incorporate biodigesters, which recover biogas from sludge, reducing emissions while generating renewable energy to power the production line. This is a key factor enabling the cassava starch industry to grow sustainably and in an environmentally friendly manner. Meanwhile, the semi-dry starch is fed into a flash dryer, where high-speed hot air rapidly evaporates the remaining moisture in just a few seconds. The heat source for this drying system typically comes from biomass burners, coal, firewood, or gas, combined with automatic temperature control systems to ensure energy efficiency and consistent product quality. The result is a fine, white cassava starch powder with a standard moisture content of less than 13%. After drying, the starch exits the flash dryer at a high temperature and must be cooled immediately to preserve its quality. A forced air cooling system is used, blowing controlled streams of cool, filtered air through the starch as it moves along the conveyor. Once cooled, the starch passes through a sieving system, typically a high-frequency vibrating screen or a roller-type disintegrator. These machines are designed to gently but thoroughly break down any remaining agglomerates formed during drying. This step ensures the starch has a fine, uniform texture, removes any oversized granules or residual impurities, and prepares it for precise and consistent packaging. Once the starch meets quality standards, it is transferred to an automatic packaging system. Depending on demand, the product is packed in 25 kilograms or 50 kilograms bags, or in jumbo bags weighing up to 1 ton, suitable for both consumer markets and industrial processing. From humble, soil-covered roots to a refined, pure white powder, through human hands and modern technology, a remarkable journey unfolds, producing starch that nourishes people, powers industries, and connects the world. Indonesia is known as the Kingdom of Palm Oil, producing over 51 billion bottles each year, accounting for 55% of global output. These vast palm plantations are not only the heart of Indonesian agriculture, but also bio-oil mines that sustain millions of livelihoods and supply raw materials to the world. Palm oil is astonishingly cheap, several times less expensive than soybean or olive oil, yet it's nutritionally rich, containing 3 times more beta-carotene than a carrot. And yet, behind the purity of every drop of palm oil lies an unending debate. The palm oil industry is both a silent pillar of modern civilization and a razor-sharp double-edged sword. On one side, it fuels the global economy. On the other, it raises serious concerns about environmental impact, human rights, and ethical responsibility. Labor in the palm oil sector is often linked to troubling abuses. Perhaps that's why it's called blood oil, an oil not only extracted from fruit, but also from sweat, tears, and at times, even human dignity. The magical journey of palm fruits, from their rough, spiky exterior to pure golden palm oil, begins in expansive plantations where they are carefully harvested. Only fruits that have reached peak ripeness can yield the highest quality oil. Today, harvesting can be done either manually or with mechanical assistance. In small-scale farms or hard-to-reach areas, manual harvesting is still preferred. Skilled workers often climb trees as tall as 6 meters, or use tools like long knives and poles to cut down bunches of fruit. A study in Malaysia revealed that 9.46% of palm plantation workers have suffered work-related injuries, 2 to 3 times higher than in the construction sector, and nearly 5 times the rate in transportation. Whether picked by hand or machine, the ripe red fruit bunches are swiftly loaded onto specialized trucks. These vehicles wind their way down dusty plantation roads, leaving behind palm-covered fields, carrying the fruits of human labor. Each truckload is a vital link in the journey, delivering the harvested fruit to factories, where it will be transformed into the coveted red gold. As soon as the trucks come to a stop at the factory gate, the palm fruit bunches are gently pushed off by a specialized loader. Using its large front bucket, the loader carefully scoops the ripe, crimson-red bunches onto an inclined receiving chute below. These heavy bunches begin to roll down the slope in a controlled manner to prevent bruising or damage to the fruits. At the end of the chute, the bunches drop into large conveyor hoppers waiting below. These hoppers, resembling mobile transport compartments, are deep and wide enough to keep each bunch stable during movement. From here, the fruits are gradually carried deeper into the factory, ready to undergo the next stages of processing to produce the rich, golden drops of palm oil. On its extraordinary journey, the palm fruit arrives at the factory for the cleaning phase. Here, the fruit is sterilized and disinfected using automated systems designed to eliminate impurities and harmful bacteria. This step also softens the fruit, making it easier to separate the kernel and extract the oil efficiently. Once cleaned, the palm fruit continues its journey through the separation and sorting stage. Each fruit is carefully classified, its pulp reserved for extracting crude palm oil, while the kernel, often called the seed of life, is separated for palm kernel oil production. The process begins with a bunch thresher, which uses centrifugal force and vibration to detach individual fruits from their bunches. The loose fruits are then fed into screw presses, where the mesocarp, fruit flesh, is crushed and pressed at controlled temperatures of 90 to 100 degrees Celsius to extract crude palm oil. Meanwhile, the inner kernel is sorted out using gravity and aerodynamic separation, and further pressed using vertical screw presses to obtain palm kernel oil. Here, precision in technology and meticulous classification determine the quality of every drop of oil produced. After the hard outer shell is removed, the palm kernels, containing the most valuable portion of oil, are transferred to a specialized sorting system. Here, machines use a combination of gravity and aerodynamic forces to separate the kernels that meet strict standards in size, weight, and cleanliness. These selected kernels then continue their journey to a vertical screw press, an apparatus that applies immense pressure to squeeze out the oil locked within each seed. This pressing process yields pure palm kernel oil while preserving most of the natural nutrients found in the kernels. It marks a crucial step in ensuring the oil's quality before it moves on to the subsequent refining stages. Like a key unlocking the treasure hidden within each palm fruit, oil extraction is a pivotal stage where nature's essence is transformed into golden liquid. The most common method is hot pressing, in which the fruit is cooked at high temperatures to release vibrant orange-red oil rich in natural nutrients. This is primarily carried out using screw press machines, the core technology in most palm oil factories. As the fruit is fed into the press, it is crushed and squeezed by a rotating screw shaft, applying pressure to separate the oil from the pulp. The temperature is carefully maintained between 90 to 100 degrees Celsius to break down the oil structure while preserving its valuable nutrients. The resulting crude palm oil has a distinctive color and high carotene content. However, to meet quality standards and application requirements, the oil must undergo a refining process to remove impurities and enhance its color, flavor, and stability. But the magical journey of the palm fruit does not end there. After the oil has been fully extracted, what remains, once deemed as mere waste, now opens a new chapter in the value chain. Once the essential oils are extracted from both the pulp and the kernel, a significant amount of organic residue remains, among which palm empty fruit bunches, EFBs, the fibrous, oil-free stalks, account for a large portion. Previously considered worthless byproducts, EFBs are now being redefined as a highly promising biological resource. Right after being separated from the fruit clusters, the EFBs are collected and pressed to remove moisture. This reduces their weight, making transportation to processing sites more efficient. Here, they are transformed into useful products such as animal feed, biofuel, or construction materials. This process not only minimizes waste, but also contributes to building a more sustainable palm oil industry, where every drop of oil is not merely a product of extraction, but a symbol of a closed-loop life cycle. Once the treasure trove of essence is unlocked, crude palm oil must embark on one final journey before reaching true purity. Though it can be extracted right after pressing, its deep orange hue and strong, pungent aroma often push people away at first encounter. The palm oil refining process consists of 4 main steps: neutralization with NaOH followed by warm water washing, decolorization using activated clay at 90 to 110 degrees Celsius, deodorization with superheated steam at 200 to 260 degrees Celsius under deep vacuum, and cooling to 20 degrees Celsius to crystallize and separate stearin, leaving behind a clear, pure layer of olein. Crude palm oil is like a ripe fruit, vivid, rich, yet raw and untamed. Refined oil, in contrast, resembles filtered essence, pale, sleek, and pure, but with only a hint of nature's original character. Once refined, the palm oil is directed to a fully automated packaging line. On high-speed conveyor belts, the oil is precisely filled into bottles, at speeds reaching up to 1,000 units per minute. The caps are immediately sealed using automated systems to ensure airtight preservation and prevent contamination. Next, smart sensors guide the automated labeling process, ensuring both accuracy and visual appeal before the bottles are boxed and dispatched. Finally, the packaged bottles are automatically stacked into cartons, ready to begin their journey to millions of homes, each carrying a mission. Now, let's return to the vast plantations, where the journey of palm oil begins deep in the soil. The process of growing oil palms starts with selecting high-quality hybrid seeds to ensure productivity and disease resistance. The seeds are germinated in controlled conditions for about 3 months, then transferred to nurseries to grow further. The young palms are nurtured for 9 to 12 months before they're ready to be planted in the field. Before planting, holes are dug and the soil is carefully prepared. Saplings are spaced 8 to 9 meters apart to ensure adequate sunlight and room to grow. During the first 2 to 3 years, the trees require regular weeding, fertilization, and close monitoring for pests and diseases. Around the 3rd or 4th year, the palms begin to bear fruit and enter their productive phase. With proper care, each tree can yield fruit for 25 to 30 years. From a tiny seed, the oil palm rises under the tropical sun, eventually bearing vibrant red fruit bunches, the source of precious oil used in thousands of products worldwide. Imagine standing in the middle of vast, lush cucumber fields, bathed in sunlight, stretching endlessly to the horizon. Welcome to China, the king of agriculture, where over 77 million tons of cucumbers are harvested every year, accounting for up to 80% of global production. However, production alone is not everything. When it comes to pickles, the United States is the true king, with renowned brands like Vlasic, Mount Olive, Clausen, and a pickled cucumber industry worth billions of dollars, closely tied to the fast food boom. With their sharp, salty flavor and irresistible crunch, stand out as a refreshing contrast to other pickled products like brined olives or pickled beets, offering a distinctive tanginess along with the added benefits of probiotics that help support digestion and improve gut health. Among over 100 varieties of cucumbers, only a few have thin skin, few seeds, are crunchy, and absorb flavor well, making them suitable for pickling. However, even within that group, only the high-quality 5 to 8 centimeters gherkin cucumbers, out of millions, are selected to create the tangy, crunchy pickles that are the soul of millions of jars worldwide. This explains why gherkin pickles, with a history spanning over 4,000 years, continue to exist and have become the golden spice, beloved globally and playing an essential role in the food industry. And every legend has a starting point somewhere. For pickles, the iconic sidekick that has won over millions of food lovers around the world, that journey begins in the sun-drenched, green cucumber fields. From May to July each year, the cucumber fields become more vibrant than ever as the harvest season officially begins. On the vast fields stretching endlessly, modern machines, large, precise, and powerful, have become the extended arms of farmers during the busy season. As the machine moves along each row of cucumbers, the harvesting head functions like a giant comb, brushing through each stem and guiding the vines into the machine. Inside, an automatic sorting system removes unnecessary leaves and stems while only keeping the cucumbers that meet the standards and transferring them to the conveyor belt behind. Unlike the modern potato harvesting machines from Grimm or John Deere, which are designed to dig up soil and separate potatoes from the ground with a capacity of up to 20 tons per hour, cucumber harvesting machines are built to be lighter and more precise, allowing them to harvest cucumbers without crushing the fruit, with a capacity of around 5 to 10 tons per hour. Traditional farming still yields stable cucumber harvests, but relies heavily on chemicals. In this context, organic farming, hydroponics, and greenhouses are gradually becoming the trend due to their ability to optimize yield, minimize negative environmental impacts, and address consumer concerns about pesticide residues and herbicides. Although technology has advanced significantly, it is the diligent hands of workers that still bring superior quality that machines cannot replace. Workers carefully pick each cucumber by hand, selecting those that are ripe and of the right size, then place them onto a moving conveyor belt attached to the harvesting machine or specialized trailer, helping transport the cucumbers to the storage containers quickly and gently. Manual harvesting, although much less efficient compared to modern machines with a capacity up to 15 times higher, ensures the finesse and precision that machines cannot achieve. After harvesting, trucks quickly transport the cucumbers to processing factories within 2 to 4 hours, preserving their freshness, crispness, and texture before embarking on the next secret journey, becoming the tangy, crunchy pickles that captivate the world. At the pickle processing plant, trucks carrying millions of tons of fresh cucumbers line up one after another, entering the raw material intake area. In modern factories, cucumbers are introduced into a closed-loop washing system, with multiple stages designed to ensure food safety and high input quality. First, cucumbers from transport trucks are poured into large indoor water tanks. These tanks contain clean, continuously recirculating water, often treated with ozone, diluted chlorine, or light brine to eliminate surface contaminants. The gentle water flow helps rinse off soil and debris while moving the cucumbers toward the conveyor belt without causing any bruising. Next, the cucumbers pass through a high-pressure multi-directional spray tunnel, typically 4 to 6 bar, where powerful water jets thoroughly remove dirt and bacteria. The water used in this stage is filtered and reused through a closed system involving mesh filters, activated carbon, and UV or ozone sterilization, ensuring both hygiene and resource efficiency. This process doesn't fully eliminate pesticide or chemical residues, which may remain on the fruit's surface. Therefore, to ensure consumer health and safety, factories must conduct strict checks in addition to following farming standards. Modern methods like HPLC and MS detect pesticide residues with high accuracy, with residue levels ranging from 0.05 milligram to 5 milligrams per kilogram, depending on the pesticide and regulations. Now here's where it gets interesting. There are two popular methods, each with its own secret formula for making pickles: natural fermentation for traditional and premium lines, and quick vinegar pickling for industrial products. First, for the natural fermentation method, cucumbers are sorted and then placed into large fermentation tanks, often positioned outdoors to take advantage of the ambient temperature, providing ideal conditions for fermentation. This method not only saves energy, but also promotes the growth of beneficial bacteria, which in turn creates the characteristic sour taste and increases the probiotic content in the final product. Each tank is filled with brine solution, a mixture of salt water and spices like dill, garlic, pepper, bay leaves, and others, depending on the unique recipe of each brand. The cucumbers are soaked in brine for 1 to 4 weeks, depending on the thickness of the skin, the type of product, and the desired flavor. It is the clever use of ambient temperature to promote the development of beneficial bacteria during fermentation, combined with the long soaking time, that is the key to creating the difference in flavor and crunchiness between the natural fermentation method and the quick vinegar pickling method. Once the fermentation period is complete, the pickles are carefully removed from the brine tanks and immediately transferred to the processing line for final cleaning and inspection. At this stage, each pickle is thoroughly rinsed to remove any excess brine, spices, or sediment that may have settled during fermentation. After rinsing, the pickles pass through a visual inspection system, either by trained workers or automated optical scanners, to detect and remove any defective or damaged pieces. Next, the pickles are sorted by size and shape using precision mechanical graders, ensuring uniformity in the final product. They are then transferred into filling machines, where they are packed into jars or food-grade barrels. Before sealing, each container is filled with a final brine solution, either the original fermented brine or a fresh one prepared under sterile conditions, to maintain flavor and preservation. Finally, the sealed jars undergo pasteurization in hot water baths or steam chambers, depending on the product type and shelf life requirements. This step helps to stabilize the pickles, ensuring food safety while retaining their natural crunch and probiotic benefits as much as possible. In contrast, the vinegar pickling method takes only a few hours, meeting the enormous demand with billions of jars produced worldwide each year, and a longer shelf life, all while being about 4 times cheaper than naturally fermented products for the same volume. And this is why this method is so effective. After being thoroughly washed and sorted, the cucumbers are placed directly into pre-sterilized glass jars or plastic containers to ensure absolute hygiene. Before the cucumbers are added, dry spices such as dill, garlic, mustard seeds, black pepper, and bay leaves are added to infuse natural fragrance. The cucumbers are then automatically divided into the glass jars. In addition to whole pickles, many products are also sliced into rounds, cut into chunks, or shaped in various ways, perfect for topping McDonald's or Burger King's burgers, or served with salads and sandwiches at chains like Subway and KFC. After the cucumbers are divided into jars, they are moved to the brine filling area, where the soaking solution is added to complete the flavor and preservation structure of the product. The key difference in this step lies in one essential ingredient: vinegar. For industrial pickle products, due to the lack of natural fermentation time, The brine solution must include vinegar, acetic acid, at a ratio of 5 to 10%, combined with salt, sugar, and other spices. While the natural fermentation method requires refrigeration to maintain freshness and is typically consumed within a few months, vinegar provides an immediate sour taste. It also acts as a natural preservative, allowing the product to be stored at room temperature for up to a year or longer, making it more convenient for large-scale distribution in the global industry. For industrial pickle lines, this is also the beginning of the short fermentation process, which is strictly controlled for temperature and humidity, ensuring the product achieves a consistent flavor and standard crunchiness. So is naturally fermented pickled cucumber or quick vinegar pickled cucumber your idea of the perfect jar of pickles? The next step is pasteurization. Typically, the jars of pickles are placed in a continuous pasteurizer or high-pressure retort, where they are heated to a temperature between 80 degrees Celsius and 100 degrees Celsius for 10 to 30 minutes. After leaving the heat chamber, the product is rapidly cooled by passing through a cold water spray system, combined with high-powered fans placed along the conveyor belt, which helps quickly lower the temperature and prevent overheating or changes in the pickle's texture. Most naturally fermented pickles don't require pasteurization, as the fermentation process creates an acidic environment that inhibits harmful bacteria and preserves beneficial probiotics. Finally, the jars of pickles are placed on a conveyor belt and pass through an automatic labeling system. Each label clearly displays the product name, ingredients, production date, and expiration date. This step ensures that all jars have consistent, accurate, and compliant information for distribution. Pickles not only play a vital role in the global economy, generating billions of dollars in revenue each year, but also serve as a cultural bridge, connecting diverse culinary traditions and bringing the distinctive sour flavor of 4,000 years of history to kitchens around the world. But what happens to the mother banana plant after the bunch is cut? The truth is, the mother plant must be sacrificed. Bananas are unique. Each plant produces just one bunch in its lifetime. Once its mission is complete, it's removed to prevent pests and diseases, and to make room for new shoots growing from its base. This is where the chopper comes in, a specialized machine that cuts and shreds the banana stalk on the spot. In just a few minutes, the old plant is cleared away, turning into fertile mulch that nourishes the soil and paves the way for a fresh new season. After harvest, transporting the heavy banana bunches without damage becomes the next key step. To do this efficiently, while maintaining freshness, many plantations turn to the agricultural cableway system, a brilliantly simple yet powerful solution and a testament to modern farming ingenuity. Instead of hauling each massive bunch out of the plantation manually, workers simply hook them onto steel hangers suspended from an overhead cable system that runs between the rows of banana trees. Once everything is ready, the railless banana train quietly glides through the tropical forest, accompanied only by the rustle of leaves, as if the bananas themselves were enjoying the ride. Time is critical when it comes to bananas. Within just 4 hours of being cut, the bunches arrive at the packing facility to preserve peak freshness. And this is where their fate is decided. Which bananas will go on to be exported, and which will stay behind to be turned into sweet, crispy banana chips. First, let's explore the export banana processing line, where every single fruit must pass through strict quality controls before reaching consumers across the globe. At the collection and pre-processing area, dedicated to fresh distribution and export, banana bunches are first stripped of their protective padding and rinsed with clean water to remove surface dust. Then, each hand of bananas is separated and immediately submerged in a cold water bath with a mild chlorine solution to wash off latex, soil, and to rapidly cool the fruit. This step is crucial in the preservation process for fresh bananas. The low temperature helps slow down respiration and delays premature ripening, maintaining the banana's freshness and firmness throughout the long export journey. At the same time, the sticky latex is completely removed, leaving the banana skins clean, shiny, and protected from dark blemishes caused by air exposure. After washing, the banana bunches are cut into smaller clusters and sorted by size, uniformity, and peel color. This step requires skill. A careless cut can snap the stems, reducing visual appeal and shortening shelf life. Only the most pristine clusters are selected, with bruised or damaged bananas removed, leaving behind only the top candidates for export. In some facilities, whole hands may be kept intact instead of being divided, depending on market demand. Bananas that meet export standards are labeled with traceability stickers, their stems wrapped in ventilated protective film and neatly arranged into cushioned carton boxes. Each box is carefully sealed, marked with a lot number and packing date, then stacked onto pallets. From there, they're loaded onto specialized trucks, heading straight to the port. Of course, not all bananas are exported fresh. A portion is sent to processing plants to be turned into deliciously crispy banana chips, golden, fragrant, and addictive with every bite. Unlike bananas meant for export, which are gently rinsed to preserve their appearance, bananas used for chips undergo a much more thorough cleaning process. Once thoroughly washed and spotless, the bananas are moved to the peeling area. Here, skilled workers use specialized knives to swiftly and precisely remove the tough green peels, ensuring the soft flesh inside remains intact, free from scratches or cracks. Each worker can peel between 400 to 600 bananas per hour, depending on the uniformity of the fruit and their level of experience. Though it may seem simple, this step is crucial. Even a small nick can cause the banana slices to warp, fry unevenly, or burn during cooking, ultimately compromising the quality of the final product. Next, the bananas are fed into a specialized slicing machine. This high-capacity machine can process thousands of bananas per hour, producing evenly thin slices at a standard thickness of around 3 millimeters. Just enough to guarantee that signature crispness while preserving the rich, starchy flavor. Thanks to sharp steel blades and a continuous cutting mechanism, the slices come out uniform in shape and size, ensuring consistent frying results with beautiful color and even texture. Immediately after slicing, the banana pieces move onto a gentle rinsing conveyor, where clean water or air jets help wash away excess starch and reduce surface stickiness, minimizing clumping during frying. Now the banana slices are ready for their big transformation, traveling down the conveyor and into a hot oil bath, the moment when their golden, crispy aroma truly comes to life. Inside the industrial fryer, thousands of banana slices are dropped into hot oil maintained at around 180 degrees Celsius, the ideal temperature for fast cooking without burning. To keep the slices from sticking together and ensure even cooking on both sides, continuous stirring is key. Workers use long-handled stainless steel mesh scoops to gently swirl the slices in circular motions. Right after frying, the banana slices are transferred onto a mesh conveyor, where cool air from industrial fans is blown upward to quickly drain excess oil and bring down the temperature. It might sound simple, but this step is absolutely critical. Not only does it remove residual oil, it also locks in the crispness, preventing the chips from turning soft or soggy during storage. Next, the crispy golden banana slices are fed into a rotating seasoning drum, a cylindrical stainless steel tumbler that spins continuously. Here, a blend of spices like salt, sugar, chili powder, cheese, or vanilla, depending on each factory's unique recipe, is poured into a hopper and evenly sprinkled onto the chips. But a giant-sized version of banana chips is just as tempting. Crispy, golden, and oversized, it's a snack you can't help but stare at. To achieve that irresistible flavor and crunch, a significant amount of oil is used during frying. On average, 1 kilogram of bananas can absorb between 15 to 30 grams of oil, depending on the thickness, frying time, and banana variety. The most commonly used oils are palm oil or refined vegetable oils, chosen for their high smoke point and cost efficiency. Before entering the automatic packing line, the banana chips go through a final quality check. Only slices that meet the required standards are allowed onto the system. Smart electronic scales then weigh the chips with precision, dividing them into pouches that match the preset weight.